Hey there guys, and welcome back. So, here's a stream deck. Problem we've been running into. First set of slides were not rigid enough, flopped over the place and canted. Technically speaking, it slid back and forth okay, but because it was canting, that was a bit of a problem and sometimes it would jam up. So, that was our first problem. Then we made this set of slides. These are H-shaped rather, slides. So they hook into both the case down here and the connecting piece up top. And these, when they were separate, had the same canting problem. Well, not the same canting problem. They had a canting problem, which we call them to bind up. So I attached the stretcher in the middle here to keep them in line. Problem is that nothing is actually rigid in plastic. So the last thing I'm going to try with this design is 5mm rod. Again, I've had this sitting around. I have a project in theory. I have two of these lengths. These are 355-ish millimeter lengths. I have two of them. I don't think I need both of them for the project that I have sitting around that I've been meaning to finish. So feel okay using these, and we'll see whether or not this doesn't work. I want to use these rather than 8mm rods just because of the size. One of those things. Let me grab an 8mm rod really quick. I should have thought of this beforehand. 1 second. Alright, so again, these this is 5/16 technically speaking, but basically 8mm. I get these for free out of the scrap pile at work. As you can see, yes, they are roughly the same size as this, as the slide that we have right now. However, one of those things, the extra plastic to go around it would make it a little bit larger than this slide. And you can see the slide profiles that we have on either side are relatively thin right now. One of those things, I could just give up and say, okay, good enough. But since I had the 5mm rod sitting around, I figure I may as well just go with the smaller rod. One of those things, this is super rigid, you know. So if this doesn't work, then it's unlikely that this would work. And therefore, it'd be a waste of time either way. Now, granted, it doesn't cost me anything to use this, except for some extra plastic in here. But I'll take the risk and use less plastic to get the job done. And go with the 5mm rod. One of those things for anybody else who's not me, who can't get these aluminum rods for free from work out of the scrap pile. You know, you'd have to buy the material anyway, so buying a 5mm rod is going to be cheaper than buying an 8mm rod. That's the logic here. So, very simply, as I said, this is simply going to replace this as the slide. And we're going to hope that it, you know, this plastic in itself slides better. Part of the canting problem is because of the friction inside of these. Based on how it's printing, you're always going to have layer lines at some point, you know, regardless of how you set it up. It's going to have layer lines in some orientation, and those layer lines are going to catch on something because we're more or less nesting in a three-dimensional space here. You know, we're sliding forwards and backwards, so any layer lines going in this direction are going to catch. We've also sliding left and right here, so any layer lines that might interface with whatever feature, not necessarily this H feature that we're using, but any other feature has a potential to catch. And same thing up and down. Up and down, obviously we have the inside here that it slides against. So since we're more or less sliding in 3 dimensions, we can't really mitigate the layer lines. So this, using the rod, should get rid of the layer lines, get rid of any friction that we're hopefully running into. It could be a problem. And otherwise, you know, if this does not work, at the very start of this design, I was thinking of a second design for stacking these. If this doesn't work, we're just going to swap out to that one because that one is dead simple. I wanted to do this one because this one's much more interesting, and the second design, technically speaking, you can access multiple layers of buttons with the second design, but it does have a tendency to get in its own way, which is why I went with this way. With this design, in theory, everything can slide back, and therefore you just have a row of buttons horizontally like this. That's the idea with the design we're working with right now. With the other design, again, you could potentially get in its way, and it gets a little bit clunky, which is why I did not go with the other design. But if this doesn't work out, we will bail, as the title says, and go over to that other design because the other design is guaranteed to work. So That is the introduction out of the way in under 5 minutes. Let's get over to Fusion. Alright, so we're coming back here and we're modifying these slides. Hop in here. Now, actually, I forgot to double look at this really quick. Okay, yeah, I only have one version of this. I couldn't remember if when we made this version, whether or not I copied it and made the change to the H bridge on a separate copy, but it appears that we did not. So it should be the left hand side. It should be the pardon me. I guess it's gonna be the same either way. I just want to get all the way back here. I want to use this as my okay. I mean, just fascinating. This is an error I have not had before. Oh, okay. That's slide 1. Understood. There we go. That's funny. I thought... Okay, whatever. Let us see. Slide attachment. Where are we at on this? Okay, this is all we've got here, so that it's fine. So its general idea is going to be similar to exactly what we've been doing before. Let me go ahead and open up a new sketch just to sketch it out really quick. That is the wrong button. Get this button out of my way. Close. Alright. So, on the sides here, we're going to have our two 5mm rods. 5 equals... These are going to go back and forth. Symmetric is what I'm looking for. I'm just going to call it 100 for the heck of it. One of those things, this is just a rough draft. So these are rods on the side right. These rods will have stoppers on the front and the back. I don't know why I'm doing 2 right now. It's kind of unnecessary to do 2. And that will stop it from sliding out of the containment. And normally I do 3. 5 is just a number in my head right now. And honestly, this could be 2mm wide. Point being, right near, these things stop it from sliding out of where we're putting it. Whole entire point. And then one of those things, the yeah, I mean, it is... I was kind of thinking, basically, to extend the top case out behind the bottom case. So the top case would actually only be connected like this. Let me get the face instead. Wow, Fusion really wants to do the double lines today. Parallel to that. Where is my right angle? There it is. Alright, so -3. Whoops, wrong -3. 3, new body. Okay, so that would be where the top case connects, and then we'd have the main case right here, roughly speaking. And then the top case, as we pull this out, their bodies, so I can't drag them right now. Actually, I should be able to drag them bodies. That and that. So as this drags out, and imagine the front case, this being on the inside of the front case would have a second support on the inside here, so that the front of this is supported, and the well, basically 2 supports inside. I guess not just the front of it. So let's say a support here and right here towards the back, against the back rather. So it always has 2 points of support, and the connecting case obviously goes back like this. Now, the one issue with how I've got this designed right now, which we were solving before and not solving here, is that, as you can see, this inside rod is only going to be the length of this box, which means that the top case is only going to move less than, like, it's not going to fully reveal the bottom one. And that is why we have it on the side and coupled by both. One of these things, I was throwing together this stream really quick, and I knew this was the general idea. I thought I had a good solution for that, and let me think for half a second. Okay, I think what I was thinking was that I drew this wrong, I think is what I was thinking. I think what I was supposed to draw here in this mock-up was actually this. I think this was actually what I meant, I originally had in mind. Out the side here, that way it doesn't interfere. Again, with everything going on, I'm trying to get a stream in, is the purpose of this stream, especially because my printer is not running right now. And my biggest problem at all points in life is needing the printer when I have a million things in the queue, you know, waiting for a million things to get through the queue in the printer. So, I think this was actually what I was thinking. So this piece, then we leave a gap in the wall here for this piece to come through, and then it works more or less like the H-bridge. I believe that's where I was at with this. So anyway, yeah, that's the general idea. If it looks a bit weird, I guess we'll figure it out, or, you know, it will become more clear as we get there. So I'm just trying to think if I'm forgetting anything. I don't think I am. I'm just looking at my pieces again really quick on the desktop. Let's see. So we're just replacing that with that, right? Kind of, sort of. Let's get the camera over here just so you can see what I'm playing with. Right, so this is more or less how we were set up before. Squeaky squeaky. Again, that friction. And I got to take the top off here in order to insert this guy, so I'm not going to. But the whole entire point of this setup is that, and actually I guess I put this in backwards, regardless. The rod, we're replacing this with the rod, right? And the rod needs to be able to extend enough such that this can sit like that. And we want it to sit inside of that, which is not a problem because, as you can see, whatever support we have here, and this is rod, so this is rigid, so it can be a bit smaller to avoid flex, but we should be good. I'm just double checking myself here. Because again, this guy in theory is going to be sitting like this. Out the side here. The two catches in the back, I guess, to drag that out. Yeah. Two catches in the back. And then right in front of that, two catches on the inside of the case. So as we drag this out, rod goes with it. No, okay, the catch can't be on the back. That's right. The catches can't be on the back. So the rod itself, I guess. Okay, so we got to build catches into this. And we'll see where we get. We'll see where we get. Again, probably should have done my homework a little better rather than just being like, you know what, I think I know what I'm doing. So, let us see. Let us come up here because it looks like my sketch for this is going to be, yeah, right there. Let me delete out as much as I can here. Yeah, actually, I guess I should come back up here and delete a whole bunch. Alright, delete that stuff. Yes, delete that stuff. Let's see what breaks. I actually don't know what that's supposed to be. We'll delete it. That slide, okay. Slide sketch, that's fine. That slides, I can delete that. Don't delete that, I guess, then. Cut, paste, slide, so we delete that. Slide attachment, offset, we can delete those guys. We'll just have to remember to put those in there. That's an orphan plane, it looks like. This is top case. Top case, huh? Oh, PCB. Okay, that's PCB. Gotcha. Okay. In that case, did I accidentally delete the PCB? That is an excellent question. Doesn't look like it now. Okay. Let's see. This mirror. Okay, that's the mirror on the bottom. Cool. Backtracking. Finding the next place where we did the slides at. This is all inside stuff. Sorry that the status bar keeps on popping up. If I could destroy it, I would, but I can't. I have no need for it on this. I guess I sometimes do. Yeah, I take it back. I do sometimes use it on this screen. I lied. Let's see. Yeah, that can be deleted. That is the bottom case, right? Yeah, the master case. So we can delete this stuff. There shouldn't be any conflicts. This is master case. This is slide cover. I think we can delete that. Oh yeah, that's the slide cover, is the thing that cover them up. Yep. And this is all relevant to be deleted. Good. Alright, cool. And I think we're there. I think we are there. Just got to find out where there is. Could have been keeping track a little bit better. That's the bottom case. That is slides. Okay, cool. There we are. Okay. Time to recreate this. Alright. Let's see. This wall is extra thick right now. I don't think we need it extra thick. It is 6 millimeters. Well, let's get designing and then we'll see where we're at. Again, the biggest problem with the slide right now is the fact that we do need it to move a certain amount in order to clear the top. I guess what I will do actually at this point, okay, let us come up here. Whoops, not there. Come up here. Change this to 3 for the time being. If we need to make it bigger, we'll make it bigger. But it does not need to, at the moment, be that big, as far as I can think. So at this point, I will go ahead and move slide attachment components, or actually align slide attachment component. And yeah, I'll take that face and put that, this is the front right here, so that's the wrong face. I want this face parallel with that, or collinear with that. So that in theory is when we have this whole entire thing extended where it's supposed to be. Now, I think if I go halfway here, I think I should be good. Let's see. Alright, I'm gonna capture position, come up here, get the mid plane. Mid plane between the front and the back, and that would be the Y mid plane. Y mid plane, slide attachment. Okay, and then let's sketch this out. It's one of those things, again, I might have to make a minor change here. Well, I might have to make a change here at any rate. Project that out too. Not that though, I kind of want the inside wall. So let's take the top case off. Top case off, cool. And give me that one. Okie dokies. So that is where we're at. Let me see my 5mm. So if this is a 3mm wall right here, which I believe it is. Okay, that's a 2mm wall. Good to know. Put that back to 5. I think I will then, in that case, go all the way in this on the inside. So let me tangent that. Grab my line. Go perpendicular. Did I have 2 lines here? No, does not look like it. Okay, good. Mid-plane. Turn these into construction lines, so they're out of my way. Turn these bodies off. Oh, shoot me. Alright. Derp, 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 derp. I was over here, forgot to switch back to slide. Try that again. Project. Okay. Okay. It's fine. Everything's fine. Don't panic. Don't panic. 5. And then perpendicular to the circle. Tangent the circle. And we are back to where we're at. Excellent. Okay. So, we toss our 3mm into here, or I guess 2mm, just because otherwise I'm going to overlap that wall. I guess it doesn't necessarily matter. I just need to make sure I don't clip it is the only thing. Did I get 2 lines here? I got 2 lines here. Fusion, you're doing an excellent job today. Let me tell you. Really enjoying it. Right angle tangent. There we go. So that is the one on the inside of the slide. Actually. Let us do this while we're here. So obviously that would go into the slide case, so I could have actually left that where it was in the slide case. That was not the purpose of what I was doing though. I was actually just getting myself set up to put the rod in first. And obviously that is not what I did. So I'm going to come here and get both of them set up now. And then I'm going to put the rod in. And let's see. So I'm at the midpoint of the top slide at this point. So I kind of want to go back, let's say another 2 or 3, two-sided. So I'm going to go back another 2 or 3 first. I guess 3. And then distance to object. Let's get the bottom case. Does the bottom case have a midplane yet? It does not. It is centered on the origin, so I'm going to grab that for right now. And then offset that by 3. Or I guess minus 3. There we go. So that's where we're at. 76, just to keep a record for my case, 76 and 76 is 152 out of my 200 or 300, 355. So I still have about 200 left of rod, which is fine. Again, I don't think I need all my rod. I'm just kind of curious how much I'm going to have left over. Is all I'm doing the math for. So let's do that really quick. And let's come back over here. And now we can extrude out. Sketches, that guy. This guy. And you'll be going forward 3. Or maybe 2. I'm trying to save a little bit of space here. I guess 3. Okay. So there's that one. And then if I go forward from that, let's turn the body off really quick. How far forward do I gotta go? Again, it's pretty rigid, so maybe we just go 5, offset 5 from here. And then, okay, I think we're on the wrong side, it looks like. There we go. So I have lost 11 millimeters at this point in order to provide some rigidity. So this is so that the top case does not, you know, flip up and down. Can't up and down. That's the point of what we're building right now, these two guys. The rail will have a cap on the end. That's why I left that 3 millimeters on the back. That way, when we slide in... actually, well, when we slide out, there we go. So when we slide out, the other option, I guess, is to pin it. Back to, I've been pinning more stuff recently on my designs, or collar. I could put a collar on it. The collars, oh, I only have 8 millimeter collars. That's right. I have 8 millimeter collars. So we're back to pinning it. And when we pull it in, the rail's not necessarily going to come with it. So the question is instead of, looks like I didn't quite extrude that first one right. Instead of doing it this way, maybe I actually glue the rod on the inside of this so that it's stuck. So the way we've been doing the slide so far is basically reminiscent of a linear slide for like your drawers in your kitchen, where it's a 3-part slide and the middle part moves half the distance in theory. Now that moves half the distance because of the bearings. We're not really doing that with our slide, but one of these deals, can we get away with this just being solid is the question. Because in theory these are the same width, okay? And if we're halfway here, if we're at the halfway point here, and we have half of the rod on the inside, in theory half the rod then fits on the inside, so we can go all the way forward. I may just need to subtract wall thickness, maybe the only thing that needs to happen. Otherwise, I think that should work. So maybe I do just glue this back guy in instead of having it stick through and then pinning it. Yeah, I guess that's probably the easiest way to do it. We'll have a cap on the front side to stop it from sliding off, I guess. We don't really... I didn't put room in there for a cap. So let's see. Two options. One is just don't pull it so far that it falls out. That's option number one. Option number two is to bring it out a little bit to get that cap on there. The third thing we want to keep an eye on, and it's one of those things that's been a while since we've worked on this design, is this distance right here, not getting too close to these guys, which it kind of looks like we are. So I'm guessing we want to bring this out then a little bit. We are taking up more space on the inside now with this design. Let's see. Unless I wanted to put a hole in the sidewall. One of the well, we're gonna have a hole in the sidewall anyway, because up until a point, because these guys need to slide into it. Whoops, get out. Burr, 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 burr. Let's see. Where's my sketch? Turn the sketch back on. And sketch is on. Control Z. What sketch are you? Oh, did I not hit Control Z far enough? I guess I didn't hit Control Z far enough. Okay, so this is my sketch over here that I was looking for. Yeah, okay, so in theory, we are below the cap right there, which is fine. Below by 1 millimeter, which is not much, but enough. Let's see. Alternatively, we can give ourselves a little bit more breathing room by... Actually, before I even say that, yeah, okay, so it does look like we're clipping the button right now, so we are going to have to make the cap wider, the box wider. The other option, which is what I was about to say, is to not make this midpoint. Try to grab that midpoint constraint. There we go. And instead, have this collinear here. Or maybe up just a little bit. .5 or something like that. And that gives us more breathing room on the top, is the purpose of that. It does not solve this problem here, where it looks like we definitely are clipping. And the third thing, if we are going to extend that out, do we want to, instead of having this tangent here, have that tangent there, since we're going to be making up the space anyway? This is an option. Let's see. Is there any reason to do that? Yeah, kind of. So, in this position, I kind of want to offset this wall a bit in order to make sure this doesn't clip. That would be the rationale. Whereas we don't have to worry about that otherwise. But it may not be that big of a deal. I may be worrying for nothing. So maybe we just leave it as is and just extend out the top case a little bit. So let's hop up here, top case. And I believe we have that written into this sketch right here, if I recall correctly. Okay, we have it parameterized, it looks like. Let's see. Switch spacing, keycap square. 73, what is the 73? plus 2 times 2. I'm guessing this 2 times 2 is my wall thickness. D8. What is D8? Parameters. What's D8? Sketch 1. D8. This is the 69 one, so it is that one. Switch spacing and keypad columns. Switch spacing is 23. Let's see. I think I am going to change this and assume that this is going to take care of my problem. I kind of want to do 4. Okay, good. That did not update too. I was curious whether or not that was linked directly to that, like I do sometimes. It is not, though. So we should be good there. And we should have extra space now. Unless... Let's see. How are you set up? Are you just coinkedinked in the corner? I guess that's just coinkedinked in the corner. Okay, that's my guess. Okay, let's finish. Oh, pardon me. Okay. Slide attachment. Or slide, I guess, rather, because we want the sketch. So let's look at this now. Yeah, okay, cool. That did solve our problem, which is good. Gives us plenty of space. Let's finish. Come up here. I did already fix that, it looks like. Cool. This rod. Let me fix the rod really quick and get rid of the extra 3 off the back. Because, again, I think I am just going to glue it in. Ooh. And then I think the way we're going to do this is come back up here. Modify Align. And one of those things, I don't always like doing it like this, but it is kind of a lot easier to make things work like that, or at least to define things like this. And again, the reason I don't do this, I mean, I've said it a million times, but the reason I don't do this is because the positioning functions do not have a timeline in them. Okay, that is all the way out the front, which is a problem. Let's see. Let me turn this off, see where we're at. Right. Yep, that makes sense. Yeah, so remember when I said I was going to just glue this in? Not going to work. The alternative is to put caps on the front and back of it, which doesn't make a terribly much amount of sense. Or in the middle, I guess. In the middle works, but no, that doesn't work. Okay, that doesn't work to begin with. Let's see. Yeah, I probably should have thought of this one a little bit more before I hopped on stream, because we are definitely let's see. Get rid of that constraint. So because this doesn't have an orientation, and what I kind of wanted to do is have these parts be on the rod itself, but the rod can spin freely is the problem. So it doesn't exactly work. Let's see. How are we gonna make this work? The only real problem we're running into is that we need to push and pull this rod at different rates, which was not a problem before because the rod could hook into both pieces when it was plastic. Right now we're just using round rod, so we can't really do that. And if we put features on it to hook into both, then we're back to a problem of plastic sliding on plastic, which was a problem before, which doesn't really solve our problem. So let's see, how do we go about this? Is it time to bail? Is it time to bail is actually a reasonable question. I kind of think it is. I kind of think it is time to bail. I don't really want to be spending this much time on this. I think there is a solution here, but well, I can't blame it on lack of sleep this weekend because I've actually been doing a good job getting to sleep at a semi-reasonable time this weekend. So it may be time to bail on this design and move on to the surefire way of setting this up. Yeah, alright. I am ready to bail. Everybody else ready to bail? Good. Good. Alright. We are now going to delete everything we just did. That's fine. We can delete stuff. Choosing not to delete stuff is not a virtue. And actually we can delete all this too because we're no longer going to have this connecting piece either. Yeah, the timeline is going to get a bit messed up. I recognize that. Let's go ahead and make sure our timeline is up to date before we proceed. Alright, what is borked? I actually do not see where you're at. Where are you at? What's the problem? I actually don't know what that problem is. Why is that problem a problem that I deleted the other ones? It's not, right? Huh? Was it just a problem because I was hitting don't cut? Is that the reason why? Because I came into this drop down menu and hit don't cut? Right here? Deselected it? Is that the problem? I guess that's the problem. Okay. Yeah, I mean, I can't think of why anything on the bottom case or the master case would matter. It would only be features on this case, and I'm pretty sure we deleted all those. So, yeah, we should be good at this point. So, at this point, and this is the front of the case. Yep, good. Let's turn that origin off. Where's that origin at? Top case, origin. Goodbye. At this point, the second method is very simply this. Second method that I thought of and was not as interesting was to run a rod straight up through the corner right here, and then to have these guys swing out. One problem I saw with that is that it might not be rigid enough, but one of those things at this point, each of these boxes is obviously not very heavy at all, and B, I'm willing to give it a shot because everything else failed. So, where do we start with this one is a good question. I guess we come back to the very first sketch and put it in here. That's what I think we're doing right now. So, how am I going to do this? I think I got to delete the back. I think I got to delete these guys. Because the rest of this, the keypad area doesn't really change. We could, so obviously this is centered. We could uncenter this. Let's see. I'm just thinking really quick. Obviously, as these swing out, as I said, they do have a little bit of a problem with flexing. I'm just thinking if there's any changes I want to make to the design I was going to run with prior to actually doing it. Any like additions to help with the flex that I need to include in this drawing right here is what I'm trying to think of. And I don't think I had any good solutions for the flex, so I think we are just where we're at right now. Now, as I said before, this guy is centered. And I think that may be, so let's make sure this guy is no longer, okay. That guy is centered on this guy at this point. Instead, this guy should be centered on the origin. And then we'll go ahead and do offsets over here. And this will be the wall thickness, I believe. I believe this is just the wall thickness. 2, 2. And then over here in this edge, I will be hopping back over to 8mm rods just because, again, they're free for me. And now I don't have a good reason to use the 5mm rods. So, we're back to 8mm. I'll leave myself, I'm going to need, I kind of want to make it a bit thicker actually because this is going to be supporting the other rows. So I'm going to make this 4. 4 may be overkill, but I'm going to make it 4 anyway just to be safe. And then we want to provide ourselves a little bit of space away from this edge just in case things interfere for the moment. I can come back and change this, but I'm just going to go ahead and give us that 1mm right there. And now, this guy, I feel like he should be collinear with that, is how this needs to be. So this wall right here can be, yeah, okay. Let's see. I'm thinking. Maybe I just leave myself 1mm on the inside here of space between this and the inside wall. And then that's how I set these guys. Oh, actually, that is not going to work there. Because on the top side, this outside guy is the guy that needs to be... I guess not tangent then. I guess just quinky-dinked on that corner. Yeah, I guess just quinky-dinked on that corner. And then for this top wall, though, I believe that is how that's going to work. Now, obviously, that ended up tangent to both of those. I'm trying to figure out whether or not there's not a constraint on the inside here that I'm missing that is causing Let me move these guys in a little bit because it's getting a bit clustered. Yeah, I guess put these here. Like that. I don't have equals on these guys. Do I? No, I don't. I don't have equals on these guys. Oh, I have collinear, that's why. Okay, this collinear constraint right here. I was trying to figure out what constraint was guaranteeing that by going tangent to this top line, that line was also tangent. It's because this is collinear with the center of this guy, and this guy is centered across the origin and square. Centered and square. So that is why. Okay, cool. So we are going to have... Actually, no, there we go. This should be 3 millimeters is how that should be. All right. Because I want a 2 millimeter wall, and then I wanted that 1 millimeter space between the rod running through the case and the 2 millimeter wall. That's what the 1 millimeter was before, but I need to also include the wall there. So that is where we're at. So let's finish this. And let's see how it updates. Sketch 5. Sketch 5. What is your problem, Mr. Sketch 5? Some constraint problem? I don't actually see it. Obviously, I have a bunch of crap in my way. Whoops. Whoopsies. Let's see. Right click, review warning. Compute failed. It is a constraint. Alright, let's get rid of top case, bottom case, master case. And here we are. Okay, so that guy got unconstrained somehow. Not entirely sure how. Turn that body off. Turn the kickstand, mounting plate, and that guy off. Cool. 5 millimeters from that. Why is that an issue? Well, that is an issue. Oh, okay. I more or less get why we have an issue right now. This is the... So basically, you see this mid plane right here? Because we're no longer square, I'm pretty sure that's why we're failing. I don't particularly know why this one's failing, but let me mid on that, I guess. Or not. Okay, let's delete. Mid on this now, okay. Oh, this circle right here, that is why. This guy, what is your problem? I guess you're supposed to be equal over here. One of those things, without going back in time and seeing what changed. This guy right here. Yeah, I don't know what this guy's doing because this guy is that guy and then that guy's midplane to there. So this guy's always going to be exactly where he's at. This circle looks like he's set off of these points. It's not. It's just set on that and then tangent to that. Okay, yeah. So that circle's going to be where it's at. So yeah, I don't know what this other circle was doing over here. Yeah, and I don't know what that... Let's see. Yeah, okay. And this, I guess the 5 millimeters right here was just for looks, basically. But yeah, okay. So how do I want to define this then? Honestly, I kind of want to define it as this line quinky-dink with that corner is kind of how I want to define it. Now the odd thing is that that line being quinky-dink with that corner did not... Oh, okay, that's why. I was going to say, it's a little weird that that did not lock the sketch down, but I guess that would make sense if that is not perpendicular. Okay, let's finish that and see what broke next. Nothing appears to have broken yet, so let's turn the body back on. Okay, so those are definitely a little large, and that is obviously off. So, okay, here's actually the problem. Let's Control Z a bunch of this stuff, because we were using the origin as our middle, and I did say, maybe not on this design. I've said before somewhere though, definitely, that there is a little bit of a problem with using the origin if you stop being symmetrical to the origin, and we are no longer symmetrical to the origin. So, in this case, we are going to have a lot of stuff broken, and therefore I'm going to Control Z a bunch of this stuff. And come back here. Let's see. Actually, you know what? I might be... So, I was going to redo this so that this was no longer centered on that. But the fact of the matter is that these holes right here, if I didn't have... these holes are based on this circle, which is around the origin. Okay, so if I did this around the origin, and the origin was now right about here, let's say, right about the edge of this, obviously that throws that off, which throws all the holes running through the thing off to begin with. So I may actually be better off leaving that as is for right now. I'm a little confused to why these guys are off, because all these keypads I don't think should have moved from where they were. So let us really quick fix that, because that should be these guys. Yep. That on that. Okay. And that on that. And then for our other, so I'm gonna have to go ahead and make a new mid plane, which is, again, something that probably should have happened to begin with. So let's hop back to right here, right after we do this, and make our mid planes. Oh, I must have the wrong mid plane. There we go. Wrong function. So that is the X mid plane. Control Z, because that's not in the top case. Actually, so it's actually, because this mid plane is being used for everything, I'm actually not terribly against putting it in the top level Stream Deck mid plane, but let us go ahead and do it in here, just because we are basing it off of this body. So that's going to be my rationale. Construction X mid plane and construction Y mid plane, please. Oh, I somehow have two already. There we go. And now we need to find our symmetrics and update them to be accurate. So, come on. Let's go. Are these guys off? These guys are off, aren't they? Okay, that would explain that one. That would explain why these guys were so far off. Okay. Because this is off. That would explain that guy. Huh. Okay, so obviously this looks ugly. Technically, the space used right here is accurate, right? We do have the correct amount of space between these guys. It's ugly, but let's see. Let's see. It's ugly, but all right. I guess I fix it. Okay. Not that one though. Don't fix that one. This one. Okie dokies. Let us turn you guys off really quick so I can see what I'm doing. Turn the bodies off really quick. Project the midplane. Delete these guys. Actually, don't project the midplane. Delete these guys. And go center to this button. That sounds like the easiest way to do this. There is that. Okie dokies. And now it is just a matter of distance. How far apart, and I guess leave the same amount of space on this guy, on this side, as on that side. I guess is how I'm going to do it. The point of these two is that I could put larger buttons in here, you know, double-ish wide buttons, but I don't want them so off a square here that they look ridiculous like they were. So one of those things I think I might, well, I don't think I might have, I'm 99.9% sure that I lost a little bit of space on these buttons, but I don't think I'm going to complain about it because the aesthetics of it being even is more important. This is you guys, right? Align. Not there. Stop. I just want the face, not the center point, please. There we go. Align. There. Okay. And let me actually, before, nah, not before. Yeah, not before. Let us come back here. This is a completely different thought. This is not the thought I was about to say out loud. Don't worry about it. Access through two planes. That and that. And Control Z. Top case. Try that again. Access through two planes. Boink boink. Okay. And this is the Z mid-plane. XY mid-plane axis. Z. There we go. And now this will replace our circular extrudes or patterns. So this one right here, select that axis instead. That actually did not work. Okay. Yeah, because my buttons are low. Okay. Control Z. No, yeah, no, yeah, no. So it makes sense, I guess, that this is what you call it. That is there. That is there. That is there. That is 1.5. So I guess that's okay. So Control Z. Let me do this really quick. Let me just make sure. 1.54, or maybe this edge to that face instead. 1.3. Edge to that face to, yeah, see, why is this? Because the spacing vertically here should be accurate. Let me do this really quick. Project that and that and that. Okay. And then let me just do this really quick to make sure that this definitely looks incorrect. So if I'm tangent to that, that's where I'm at. If this is equal to that, then I guess that is tangent to that. Okay, it doesn't look like it's the same distance, but I guess it is. Okay. Okay, I guess it is. I was trying to figure out because it should in theory be the same distance, but it was not looking like it. It was looking a heck of a lot closer. But evidently, if I drag this line straight across, you know. So there's that. And then there's that. So the top edge, the highest edge here, is still tangent to that. And the lowest edge here is still tangent to that. So, it's just a matter of this corner distance. But, let's see. This is 3 plus 2.45. So, yeah, I mean, there's my 3 right there, right? Yeah, 1.25. 1.25 is not right, though. Let me do this here, then. Yeah, that's 2.75. 2.7. Okay. No, that's... Okay. Let's do this, then. Let's redefine how that is put there, in that case. And I actually am going to want, yeah, that on that line though. What was mid-plane? What did mid-plane look like? See, why wasn't I using, I had a reason for not using mid-plane. I recall there being a reason. I do not remember what that reason was, but as you can see, that obviously looks a heck of a lot better. I cannot recall what the reason was that I wasn't using mid-plane. Okay, well, that is one mystery more or less solved. One potential issue resolved. These round things should still be accurate. Yes. Yes, they are. Okay. Let's see. These guys might have a little bit of an issue. They do. So. Do they though? Huh, hold on. Let me look at what these how these are actually set up. Okay, they're not constrained. That is good to know. They are not constrained. That would explain some things. Bottom case, master case, tilt mount off. So, you are not constrained, which means that you need to be fixed-ed. Turn the body off, please. Thank y'all. And the master case is the same size as the cases above it. Therefore, going corner to corner should still be on our, should still be on our mid-planes. Still work with our mid-planes, I guess I should say. Let's get you parallel to that. I don't think it necessarily matters which way, but turn the body back on here. And now, we can fix these guys. Change that guy to that guy. Looks accurate. Cool. And now these guys get swapped with that guy. Okay. And I will say one thing that this one benefit we do have here is you see this extra space on the sides that we gave ourselves. I was having trouble fitting the Arduino and the shift registers into these designs. It was going to be real messy. Now we have plenty of space around the keypad to insert the Arduino and shift registers. So that is one major bonus for switching designs here. All this is the kickstand, I'm 99% sure. So none of this should have failed yet. Actually, it does fail. It does fail. Let us Control Z. Where is this drawing right here? Where is this drawing? Stop it, Windows. Stop it. Okay, there it is. And the problem is that you are on the wrong plane. Okay, so we just need to... Okay, so... Alright, I mention this all the time. We're about to see it in action. Redefine sketch plane. This guy right here. Okay. And now we're going to go ahead and... There you go. Yep, exactly as expected. We are now upside down. So that is one of the problems I have with redefining sketch planes, which is why I try not to define on predefined, unlike bodies and whatnot, is because when you redefine the plane, stuff like this happens. So instead of redefining the plane, the way I'm going to fix this one is we're going to do our extrude from object and select the correct plane instead. Interestingly, oh, okay, it's not this guy though. It is the other guy. This guy right here. There we go. So this guy is going to be from object. There we go. And that guy. Okay. And same thing with this guy, object, X-plane. Okay. And then when we do the rest of this stuff, unfortunately, similar problems are going to arise. So this is going to be likewise X-plane. And X-plane. I feel like something did not go accurately here. That's not right, right? Control Z. Oh no, I guess that is right. Question mark? Question mark? Yeah, that is right. Okay, cool. Alright, now the rest of this should hopefully update correctly. It looks like it does. And there we go, there's our next guy. That is, again, from the X-plane. Okie dokies, artichokes. And what else we got here? These guys. This guy is going to be right, the initial guy. The initial guy, I believe, is accurate, so it is just the mirrors. And our mirror plane is now the Y, right? Nope, the X. Still the X, that's right, it's in the same plane as the other guys. Derp. Le derp. Please. Thank you. There we go. And let's see where we're at. This does not actually matter. Back to this clamp. I'm not even sure I'm going to use this clamp, to be honest. There's a couple problems with it. So I'm not going to bother fixing it in the CAD just yet. And now we are on to this piece right here, which, funny thing is that it did not break this time. Yeah, and honestly, it looks fine to me, so I'm just going to hop in here and delete this random circle, which is unnecessary. And I'm pretty sure that that extruded correctly, like the way... Oh, no, it did not. So let's see. Circular. Okay, it was on that circle, so that circle is off, it looks like. So let's take a look at that circle. Turn some of this stuff off. Shrink, shrink, shrink. Bottom case off. Master case off. Tilt mount is fine, honestly, having on. No, it's not. I take it back. Turn it off. Turn it off. Okay. So this circle is no longer centered. Is part of our problem. The circle is centered on the origin is the problem. So that is our problem, and that is actually a good reason why this guy should be here. So we can put it back in, do that. Never mind, I take it back. That is not going to work. Let's see. So I don't really want... Okay, let's do this. Okay. Let's grab our Z-axis that we made and never used. Project Z-axis, okay, and put that circle on that Z-axis. There we go. And that, hopefully, will have fixed our problem. There we go. Excellent. And what did the rest of you guys do? Let's see. Oh, you're the holes in the bottom. So actually, you should be fixed as well. That should be accurate. Oh, mirror. That is what's not accurate. Mirror is the X-plane. X-plane. There we go. Alrighty. Now, the last thing that needs to happen is we now need to get the whole entire swivel action going. Now that we are sure that everything is up to date with the mirrors and whatnot, the new references, now we get the whole entire swivel put into place. So, grabbing some coffee. At this point, let's see. So in order to make sure it didn't tweak, I was going to build it into the case. Yeah, we can still do that. That's fine. Okay. So let's come back up here to top case. And I think I can get away with doing it at the very end here. Let's see what happens. So there's basically two components. There's one on the top case and one on the bottom case. The one on the top case, it may just honestly be the hole. The alternative is, because I'm a bit concerned about it twerking, about it falling out of alignment, is to extrude out support on the other side here. But for the time being, we may want to just cut and see what happens. Two-sided all and all, and let's do everything except for the tilt mount, this stuff down here. So the master case, actually the master case, not the master case. We're not going to do the master case. Yeah, so just the top and the bottom then. Okay, that's fine. So there is that. So the rod will stop in the master case. It will just bottom out down here. I was thinking about putting a holder for it down here. I don't know that's necessary just because it's going to be held straight by all the other pieces. So this case, that case, the case above it, top and bottom, you know. So I don't see it. I guess maybe I should. The only reason I was going to avoid doing that is because of this little bolt right here. This little bolt looks like it's going to be in the way, but actually, okay, there we go. That is something we can do. Okay. So in the master case, you see how we're going to hit that bolt? So instead of trying to put something on the floor, I'll actually put it against the wall. I'll just put a little flag stand against the wall, and we will say that's good enough. So let us extrude, and I should be able to just use this sketch, honestly. I'm pretty sure. Let's turn some stuff. I don't have to turn this stuff off. Let's just turn off the body. So I believe I can just do this. Turn off the bottom case from object here, and then let's go like -5, -10 maybe. Join. Yeah, so that's just what I'm thinking. That way I can still get to that bolt to attach the kickstand, and this gives me a little flag stand type deal to hold the bottom of the shaft in place. Obviously, it doesn't keep it from being pulled up and out, but there's no reason why it really should ever be pulled up and out. So I'm not particularly concerned about that. So we'll go ahead and join that. So that's that one. Now for the bottom case, what I'm looking at doing here. This is one of those deals where I may need a second bottom case. Thinking, processing. Let's see. Yeah, I think so. Let's hop up here just so that we can discuss. Basically, my only thing that I want to accomplish here is getting to it. Object there. 10. This is the only thing I really want to accomplish. In order to, so the one on top is the one that's going to want to pivot as you swing it out. It's going to be the one above, the one that you're swinging out actually. So in order to help prevent that, I was thinking about, let's see, we have features on the bottom of this anyway, right? Yeah, the top case has features anyway on the bottom. So anyway, what I was thinking about doing, why I said bottom case, was putting this on the bottom of the bottom case. That is a bit obnoxious. The way we're printing the bottom case is my biggest issue. The bottom case obviously is a shell that wants to be printed exactly in this orientation. So sticking this on the bottom is a bit of a problem. I'm thinking about just making this a washer, new component, okay? Bushing, whatever you want to call it. And leaving it at that, just having it a piece that provides offset from the lower case. The only reason I'm hesitating to do that is that, again, when you swing the bottom case, so imagine another bottom case up here, when you swing that out, if it doesn't have enough support, which again, we might be able to circumvent that. We may be able to circumvent that on the inside, but if it doesn't have enough support when it swings out, it's just going to tilt, right? It's going to pivot off, which is the one problem with this design. So the one solution I guess that I could do is do the flag stand pull like I did on the bottom case and trust that to be rigid enough. Yeah, all right, you know what? I'm willing to go with that one. Okay. I've just talked myself into it. So this will be a new component right here, and this is just going to be a washer. The only question is how tall it needs to be, which frankly, it only needs to be slightly larger than the keycaps, right? And the keycaps are only going to be like 2 millimeters thick. I haven't actually gotten around to printing keycaps for these guys yet, but they're not going to be more than like 2 or 3 millimeters at most, if not 1. And no, probably 2. But point being is, if I go 5 here, that should give me plenty of space between keys. So this is a new component. This is a washer. We are starting from the top, right? Yeah. Bushing, washer, offset, standoff, whatever you want to call it. That will keep space between the levels. So there is that. And now on the bottom case, I'm going to do the same exact thing I did on the master case, which is just extrude that down. And I'm going to trust that to give this enough rigidity to survive. And we can actually go all the way down to the floor. With this guy, I'm pretty sure, I don't think we lose anything. I don't think we break anything by going all the way down to the floor like this. So that hopefully should keep it rigid enough so that it doesn't tilt and cant out of position when we swing it out. Part of me would like to put something like on the edge here to keep it, to help it in case it does. So let me go ahead and come up here just so that I can demonstrate. Spacer, I'm just going to call this. One thing is, I should mention, is obviously I did not name any of my sketches this time. I said that's something I'd be working on. That is, my excuse here is that I wasn't naming any of the other sketches in this design, so I mean, why start now is kind of a bad argument. At the same time, it's kind of how I feel. So there's that. Plastic. Or no, we already have orange. Pink it is. Yeah, okay, that is up. Good. Alright, anyway, on to the discussion at hand. Let me go ahead and I guess components, that guy and that guy, create copy and drag up. Good enough. Okay. So this guy, when this guy rotates, okay, never mind. Go back. Hit OK. Rigid group this really quick. Yeah. Sure. I don't care. And as built joint. That. Revolve around there. Okie dokies. Cool. So, as this swings out, as I've been saying, I'm concerned that it tilts a little bit over here. So part of me is tempted to throw something right here to help push this front edge up as it comes by. So imagine a little hemisphere, half circle on this front ledge, just in case this front edge is down a little bit, to push it back up above the keys. And it would also support this corner in the long run. We could also do the same thing over in this corner. We could put another support just to, again, help support it over time. The only issue, well, the issue that we ran into before when we tried to put this spacer in attached to the object is that both of these objects, that guy wants to be printed on this face because it has features on the bottom, so we can't really put the hemisphere here. And we can't really put the hemisphere on this guy either, because this guy wants to be printed with this against the flat, against the print bed. So that is the only reason I'm going to leave it off for now. Otherwise, this is how this model works. It's, in case you were having a problem keeping up when I was talking about it, I was explaining myself correctly, accurately, descriptively enough. That is the new design for it. And again, hopefully this little flag stand on the inside keeps this one rigid enough that we don't have this bowing effect as it swings out to the side. Otherwise, the way I'm thinking of this being used is that you actually swing out the one you want to use. So for example, imagine this being sideways so it's not facing you, and then you swing, if you want this top one, you swing it over to face you hit your button, and then you can swing it back, grab another one if you need to. The only problem obviously is with this guy right here. However, what we could do is we could actually separate this off, put a lid on the master case, and then have a gap, in little gap. I mean, it doesn't have to be much, honestly. It could be even a smaller washer, spacer between this guy and the master case. Just something so that there's not really too much friction. And if any bowing occurs, to offset it. And then each of these could swing off. So that is where we're at. And actually, I only did this temporarily, but I think I'll go ahead and leave this copy in here just for demonstration purposes. So this is the new design. I will go ahead and get this printed while I work on the coiler decoiler code. And that is everything. Hopefully this is the final redesign on the Stream Deck. It's a shame we couldn't get the other one to work, but at this point, kind of have to move forward with life. This has been a project for entirely too long. At this point, this was a project weeks before I did the circuit board, big reveal. So this is something that definitely needed to get done, and I really need to free up some project time for other projects, such as a new camera mount. And honestly, I'm getting used to the microphone, working around the microphone, so I don't know that I'll do the microphone mount. But the other thing that I've been thinking is that whatever camera mount I make may very well be just as useful as a microphone mount. In other words, just instead of mounting the camera, mount the microphone. So it may be one of these 2-in-1 deals where I design something for the camera and then just go ahead and use it for the microphone as well. We'll see what happens there. But again, fairly optimistic that this is simple enough that it's going to actually work. I hate to sound like a broken record here, but I really, really wanted the other design to work because the other design is much more interesting. Unfortunately, as I like to say, that is not the world we live in. So this is what we're compromising on for the time being until we decide that we don't like it enough that we need to do a redesign. So, as always, if you've been watching, thank you. And otherwise, I hope you have a great and wonderful day, afternoon, or evening, wherever you're in the world. And I will catch you next time.